Objective 7 then says, predict and explain the effect on equilibrium using the collision theory for the following situations. So I'm going to break uh, Objective 7 into 3 different short videos. One looking at whether you add or remove one of the reactants or products, then if you change the volume or pressure, and then finally the effective temperature. So adding or removing reactant or product, this is probably the easiest to understand. If you add reactant, you now have more reactant particles to collide. So it'd just be like increasing the surface area or increasing the concentration. You've increased the number of reactant particles colliding. And if more reactant particles collide, you end up making more product. So I like to think of this as pushing the equilibrium to the right. So you crowded the reactant side more, and as a result, more product forms and the equilibrium moves to the right. If you remove a reactant, then we see just the opposite. There's a decrease in collisions on the reactant side. So that means less product is forming. There's more product continuing to collide, and you're going to end up forming more reactant. So when you remove from the reactant side, some of the product reforms reactant, which moves over to that left side, and it pulls the equilibrium to the left. So if you could think of adding or removing your reactant, like adding or removing weight to a teeter-totter, if you add the weight, you slide some over to the opposite side to rebalance it. But if you remove weight, you have to pull some weight over to the side you removed it from to rebalance it. So then product is very similar. If you add product, you add collisions to the product side, and you end up making more reactant, or you push the equilibrium to the left to the reactant side. But when you remove a product, you decrease the collisions on the product side, so you end up with the reactants colliding more and forming product to replace that product that was removed, and it pulls the equilibrium to the right.